Have you ever wondered where the atoms in your body came from? Before stars, planets, or even galaxies existed, the universe created its first elements, in just the first few minutes after the Big Bang. This miraculous event is called Big Bang nucleosynthesis, and it laid the foundation for all matter as we know it. Let's rewind time about 13.8 billion years. The universe has just exploded into existence. In the first seconds, it's unimaginably hot, trillions of degrees, and full of a dense soup of energy, quarks, and gluons. As it cools, quarks bind into protons and neutrons, the basic building blocks of atomic nuclei. By the end of the first second, most of the universe is made up of free protons, which are just hydrogen nuclei, and neutrons. But these particles don't stay idle. They're waiting for the next big step, fusion. However, the universe is still too hot for atomic nuclei to be stable. Anytime protons and neutrons try to bind, high-energy photons break them apart.
Fast forward to about 3 minutes after the Big Bang. The universe has now cooled to around 1 billion degrees Celsius, cold enough for protons and neutrons to stick together without being blasted apart. This begins a short but crucial period known as nucleosynthesis, lasting roughly from 3 to 20 minutes. During this brief window, the fundamental particles fused, protons and neutrons combined to form the nuclei of light elements. The primary products were isotopes of hydrogen like deuterium and especially helium-4. Trace amounts of helium-3 and lithium-7 were also created. This period was fleeting because the conditions changed rapidly. Before 3 minutes, it was simply too hot. Any nuclei that formed were instantly broken apart by high-energy photons. After about 20 minutes, the universe had expanded and cooled too much. The density dropped, and the temperature fell below the point required for fusion reactions to continue efficiently. This short burst of activity determined the initial elemental composition of the universe. About 75% hydrogen and 25% helium by mass, with tiny traces of lithium. Heavier elements like carbon and oxygen wouldn't appear until much later, forged in the hearts of the first stars. The nucleosynthesis window set the stage for everything that followed.
Several light elements formed during this time. These were the universe's initial building blocks. Hydrogen formed, mostly as a single protons. Helium-4 was created, made of 2 protons and 2 neutrons. Deuterium, a heavy form of hydrogen with 1 neutron, also appeared. Helium-3, a lighter helium isotope, was synthesized. Lithium-7 formed in trace amounts. These were the primary products of this cosmic forging. About 75% of the mass of the universe became hydrogen. Approximately 25% became helium. Lithium and deuterium were much rarer, but still important components. These light elements were the universe's first stable matter beyond individual protons and neutrons. They represent the initial composition of the cosmos. Everything that came later, stars, galaxies, planets, and life, was built from these fundamental ingredients. Why only light elements? You might wonder, why didn't heavier elements form at this time? The reason is time and stability. The universe expanded and cooled too quickly for complex fusion chains. Plus, there's a key gap. No stable nuclei exist with 5 or 8 nucleons, which blocks the path to heavier elements like carbon or oxygen. So, nucleosynthesis essentially stopped after lithium. Visual, fusion path diagrams stopping at lithium, with a barrier at heavier elements. Around 20 minutes after the Big Bang, a critical shift occurred. The rapidly expanding universe had cooled sufficiently, dropping below the immense temperatures required for nuclear fusion to continue. This marked the definitive end of Big Bang nucleosynthesis. With fusion ceasing, any free neutrons not already bound within atomic nuclei quickly decayed into protons. The light elements that had formed, primarily hydrogen and helium, with trace amounts of lithium, were now locked in. Their creation was complete. These primordial elements, forged in the universe's earliest moments, became the fundamental raw material. They would patiently await the gravitational forces that would eventually draw them together, igniting the very first stars and beginning the cosmic cycle of element creation. Big Bang nucleosynthesis is powerful evidence for the Big Bang theory. Its predicted hydrogen, helium, and lithium ratios match what we observe in the oldest stars and galaxies. Without this early element factory, stars wouldn't have ignited, and life wouldn't have stood a chance. It's the universe's foundational chemistry. In just a few minutes, the universe created the basic elements that everything else is built from: planets, stars, water, and you. From the tiniest proton to the vast cosmos, it all began with a few simple fusions in the first heartbeat of the universe. Consider this profound truth. Every atom in your body, every element that forms our world, was forged in the fiery crucible of stars or the universe's earliest moments. We are, quite literally, stardust, walking and wondering. This journey from the infinitely small to the immeasurably vast is our shared heritage. It's a story of cosmic evolution, still unfolding, inviting us to look deeper, to question, and to marvel at the intricate dance of existence. What wonders will we uncover next in this grand, ongoing narrative?
If this video bent your brain, then imagine what else we're about to uncover. Subscribe to at Pro Know, where we turn the universe into understandable science. Because remember, knowledge comes with a price, but in my case, you just need to subscribe. Stay curious, question everything, and until next time, keep exploring the impossible.